So, have you been singing the quadratic formula song? If not out loud, in your head? You don't have to admit it right now. I know it's happening. Anyway, before we get started today, sort of with an interesting piece of the quadratic formula, I thought we could start by just doing a reteach in case you just need to hear it said or something doesn't feel right. So what I'd like you to do right now is just pause the video, and I'd like you to solve this quadratic equation. Find the solutions. Oh, by the way, find the roots. Oh, by the way, find the x-intercepts. That's what you're finding by using the quadratic formula. So pause the video, come back, and we'll see how you did, and I'll do a quick reteach. Okay, now that you're back, remember that in order to use the quadratic formula, it needs to have everybody, all three terms on one side. Unlike completing the square where we need the constant on the other side, this is more like factoring. We need everybody on one side, and this one is good to go. I look, my A is going to be the invisible 1, my B is going to be a positive 5, my C is going to be 3. You don't have to write that down. I just wanted to have it there so you can see. And now I'm going to take the opposite of B plus or minus the square root of B squared minus 4 times A times C. Don't forget, when we're doing it in the calculator, we're going to hit enter at this point, and then we're going to divide it by 2 times A. Where did this formula come from? We basically took ax squared plus bx plus c and equals 0, and we solved it. We transformed the formula using completing the square, and then you just get this formula. And I did that in the last video. Okay, so now let's take a look and do our substitutions. So the first thing I would want to see is the substitution. So you'll see I put the negative b plus or minus the square root. I'm absolutely okay if you square the b and write that down. But I do want to see the minus times 4 times a, which is 1, times c, which is 3. And if you're going to make a mistake, it will be right in here generally. And then over 2 times a, which is 2, and I'm absolutely okay that you would write your substitution like this. The next step is to get under the square root. We're going to come up with a new name for that b squared minus 4ac today. But you're going to take 25 minus, now this would be 4 times 3, minus 12. And usually what happens is, especially if there's negatives on the a and c, things start to go wrong in here, so be careful. So the next thing I'd want to see is this substitution, that 25 minus 12. I definitely want to see this. Now, if you put a step in between here, that's fine, but I absolutely need to see the substitution, and then I need to see the simplification. I need to know what this number is. This is now where I would pick up the calculator, and I would, in the calculator, put negative 5, not minus, negative 5 plus square root of 13, and then you must hit equals or enter. Then divide it by 2. Then I would write that down. I would go back, second problem in the calculator, negative 5 minus the square root of 13, hit enter, divide it by 2, and I get the second answer. Generally speaking, we're rounding to the hundredths, but I just want to make sure, we talk a little bit about rounding. So you should have gotten this, and if we're going to round this guy to the hundredth, that 7 is going to bump the 9 up, which is going to bump the 6 up. And over here, the 2 is going to have no effect on the 0. So if you round it to the 100th, that's what you should have gotten. Now you can check these answers. You can put in that negative 0.7 in for x in the original and do the math, and it should almost equal 0. Now you heard me say almost. That's because we rounded. You won't get a perfect check. And then you would do a second check. Square the negative 4.3 plus 5 times negative 4.3 plus 3, and you can actually check your answers. But just remember, with the rounding, it won't be a perfect check. Okay, so we're going to go forward today, and I'm going to give you a new name. It's really not a tough concept today. You probably already have sort of seen this. But underneath the square root, the b squared minus 4ac has a special name. It's called the discriminant. And the discriminant tells us what's happening. Without doing the whole quadratic formula, it tells us what's happening sort of with this quadratic equation. So the discriminant is b squared minus 4ac, and what it can tell you is how many solutions there are. It won't tell you what they are. You have to do the whole formula for that. But it will tell you, will you have 2 solutions, 1 solution, or no solutions at all? And again, we're working on the real numbers. When you get to Algebra 2, we'll start talking about complex. But right now, we're all on the real number plane. So let's take a look at this discriminant and see what I mean. So if you were to take the b squared minus 4ac, so you square whatever the b number is, you subtract 4 times the a times the c, and your result is a positive number, like the one we just did, by the way. See the 13? Then that means that there are 2 solutions. And if we think about the picture, if your parabola has a negative a so that it opens down, it would look something like this. See, it's going to hit that x-axis in 2 places. There's your 2 solutions. If that a is positive and it opens up, it might look something like this. In other words, the parabola, when you draw it, will hit the x-axis, intercept the x-axis in 2 spots. So when you find the discriminant, you don't know what those 2 spots are, but you do know there are 2 of them. Now let's say that underneath the square root, you don't get a positive number, you get 0. If you get 0, think about it. The square root is 0. There is no positive or negative difference. So in that case, there would only be 1 solution. So again, if your a was negative, so that you know the parabola opens down, it's going to hit the x-axis in exactly 1 spot. It will be vertexed on the x-axis. If your a is positive, it might look something like this, again, with the vertex on the x-axis, and that parabola is intercepting it only in 1 place. That's when the discriminant is 0. Okay, there's one other case. What happens if you get a negative number under the square root and you have that no solution kind of an answer? Well, that means that if it's opening up, it's vertexed above the x-axis and opening up. And if it's opening down, it's vertex below and opening down. It never hits the x-axis. So the discriminant can give you the answer of how many solutions there are. Again, it doesn't tell you what they are. You have to do the whole quadratic formula to get that, but it can, at least give you that information. So you have to think about what is the question asking. So let's take a look. See, this doesn't say find the solutions. It says tell how many solutions there are. So we're not going to do the whole quadratic. We're just going to look at the discriminant, which is the b squared minus 4ac. So what I'd like you to do right now is to pause the video and use your discriminant and take your b squared minus 4 times a times c and determine how many solutions each one of these 3 problems has. And when you're all set, come back and we'll check them together. Okay, let's see what we got. So in the first one, you would have taken the -3 and squared it. And be careful, remember to catch the -3 in the gloves in the calculator. This should be 9, not -9. Times -4 times a, which is the invisible 1, times c, which is 2. And you would get 9 minus 8. See that positive 1? That tells you, since it's a positive number, this parabola is going to hit the x-axis and have 2 solutions, 2 real solutions. And it's going to be opening up because of the invisible positive 1. So it's a parabola opening up, hitting the x-axis in 2 spots. Okay, the next one, you would have had the -2 squared, which is 4, minus 4 times 6 times 4. You'd get 4 minus 96. You get a negative number, and this would have no real solutions. Again, because the a is positive, this parabola is opening up, but its vertex is above the x-axis. It has no real solution. Let me just show you what I mean. It looks kind of like this guy. Okay, the last one. You're going to take 5 squared minus 4 times a -3 times a -1. And this is where a lot of people can go south with all the negatives. So be very careful. A negative times a negative is a positive, and a positive times a negative is a negative. You're going to have 25 minus, in this case, 12, gets a positive 13, which is the discriminant we just got on the SMART problem, and that will give you 2 real solutions. So I did not give you one that came out to 0. And if you had gotten a discriminant of 0, it would have been the one real solution. Okay, so, where is this helpful? Okay, so here's an example, a word problem, an application problem. And this is actually something that happens quite a bit in life. A construction worker on the ground tosses an apple up to a fellow worker who is 20 feet above the ground. The starting height of the apple is 5 feet. So that's his hand is 5 feet above the ground when he releases the apple. And he's going to throw it up there with a velocity. He's going to put force behind it that's 30 feet per second. And notice that it asks, will the apple reach the worker? It doesn't ask when. It's just asking, will the apple reach the worker? Let me go back to these pictures and let's talk about what could happen when you throw an apple up. So I'm going to go back here and let's just take a look here. One thing that could happen, so right here, imagine that the worker is sitting on the x-axis, right? When you throw that apple up, you could throw it up with such force that if he misses it on the way up, he has a second chance to catch it on the way down. So, oops, went above my hand, but it comes back down and I catch it. So there's actually 2 chances to catch it. If the discriminant is positive, he would have 2 chances to catch it. Now let's imagine he's sitting there and, man, you are perfect. You throw it up with force that exactly reaches his hand. He has 1 chance to catch it. If the discriminant was 0, he'd have that 1 chance to catch it. Okay, feeling a little weak today? The construction worker is sitting on the x-axis and you throw it up and it doesn't even come close. He has no chance. So if the discriminant was negative, he's not going to be able to catch it because it's way below his hand. Back to the problem. So when this question asks, will the apple reach the worker? We don't have to do the entire quadratic formula. We just need to check the discriminant. And if the discriminant is positive, he would have 2 chances. So that's a yay. If it is 0, he would have 1 chance. That's still a yay. But if the discriminant is negative, it never reaches him. And the answer to will the apple reach the worker would be no. Now you're going to remember our vertical motion. So the h here is the end height. The t is the time in seconds. The v is the initial velocity. And s is the start height. If I'm not mistaken, if I didn't mention this before, sometimes our book might use a c here, or some textbooks. I actually like the S and the H better. All right, so let's go back to our problem. The worker, where we need to get the apple, is 20 feet above the ground, so our H is going to be a 20. The velocity, we're looking for that force, is 30 feet per second. And the start height, his arm is 5 feet off the ground when he releases the apple. Now we're going to substitute those in appropriately, right? Okay, we are not ready to go right now, because we need a 0 over here. So we're going to subtract the 20 from both sides. And now we are ready to use our discriminant. We need b squared minus 4 times a times c. Okay, so we're not looking at these over here. We're looking right here, okay? So b squared would be 30 squared minus 4 times the negative 16 times the negative 15. Now remember, a negative times a negative is a positive times a negative. We're going to have a minus in here. So 30 squared minus the 4 times the 16 times the 15. And look right here. When we subtract 90 minus 960, we're going to get a negative number. So that is that case where you didn't put enough force behind the apple, so it's going to come back down to you and never reach the worker. So the answer is no, it will not reach the worker. So there is kind of the benefit of the discriminant, if that's your question. If it had reached the worker, if the discriminant had been positive or 0, then we could have said, how long will it take? And we could have solved the whole quadratic, and that would have given us the seconds that it would take, or partial seconds, to get to the worker. So the discriminant is a pretty cool thing. I will attach the notes pages of this video to Classroom, so you'll have those as well. And I hope that you're doing great and singing the song, everybody. Have a great day.